I guess I'm live. Bruh. I was live for, or I was quote unquote live for 4 to 5 minutes. I thought I was live, but I wasn't live. Okay, well, I guess that's fine. It doesn't really matter. I'm not doing this to be live. I'm doing this to actually try to improve. So it's not really that big of a loss. But at the same time, it would have been nice to be live. But nonetheless, hopefully everyone is doing well. I'm gonna do the intro again, I guess. So this is like a chill stream. I'll just be working on maths and just talking. If someone says something in the chat, I'll answer. I'm not gonna be quiet or whatever. I'll just chill and talk with everyone, and at the same time do some mathematics. Currently, I'm prepping for an exercise class I have tomorrow. I don't want to be super unprepared. I'm doing kind of preparatory stuff. And I decided to do the stream on this channel. I've done 2 of these streams, and they're on my second channel. Granted, it was a long time ago, but yeah. So I thought that it was relevant to this channel to do like a more chill stream, and yeah, hopefully everyone is doing well, and hopefully the mic and stuff is working, and maybe it's too quiet. It could very well be too quiet. I don't really know how to set up the mic that well. It's awfully quiet. I have noticed, compared to like my other mics, even if I turn the gain all the way up. So yeah, I have my like drawing tablet here as well, so you can see what I'm actually writing down. So I was in the process of doing the proof that I guess this proof. So the absolute value of x is less than or equal if, yeah, I guess you can read this. Hello. I literally thought I was live for 45 minutes. Okay. Let's continue. Really, it's really late. I'll probably end the stream in like 45 minutes, since I want to get some sleep. Been super sick, just chilling. How have you been? I'm doing pretty well. But yeah, I spent some time setting up the stream. The camera was almost broken for a while. I was like kind of stressed, I guess. But eventually worked out. I got it fixed, and would have liked to spend that time actually to prepare. I have also this linear algebra, or it's not really linear algebra, it's just simple algebra that maybe I'm gonna do, and then if I'm feeling really, yeah, if I have some time, I'll do this some ODE stuff. I have a linear analysis seminar tomorrow, which, to be fair, I should probably do. Oh, this is linear analysis, great. So this is linear analysis, and this is my ordinary differential equation books. These are the 2 main courses I'm taking. Also one in stats, but let's not talk about them. Yeah, so. I want to see the problems I have for tomorrow's seminar. I guess this is also maybe a good time to see how I study as well. If that's interesting to anyone. I've gotten some questions about it, so it's usually a mix of Wikipedia, other books that I randomly think about, and ChatGPT, and maybe I ask my friend. But it's mostly those 3 things: books, online, and ChatGPT. So I want to see the different. The thing is that when I look at this monitor, it seems that I'm looking at the camera or close to it, which I find kind of odd. But yeah, I'm not really looking here that much. So yeah, hopefully, I'm not sure I mean, if you have something to study, you can always join this stream, or if you just want to talk, I'm fine with talking. And if you want to join the live stream voice channel, I'm on that channel on the Discord server. Feel free to join the Discord server as well, which is linked in the description. What am I even doing? I'm not sure if can I show. I think I can show this, or maybe I shouldn't show. I have my course page open, but maybe I have my lecture name, like my the lecture and the seminar teacher's names is on the thing, so maybe I shouldn't show it actually. But I can show this page. Yeah. Hello Cube Request, Eduardo. Welcome to the stream. So I have some questions here. I found last week's seminar problems to be very fun. I did present one on the board, but I didn't do a good job actually presenting it. I realized when I was up there. I wasn't really the best. Yes, okay, so we have Rimele Beg Lemma, and never mind. We have Laplace transform 3.1, 3.2, and questions from Vriet Blad 2.22 to 2.24. Yes. Okay, let's do that. Since why the freak not? So yes, I have no idea what the Riemann Lebesgue lemma actually states. I have no idea. So I'm probably gonna read all this. My lecturer yesterday, or last week, Friday, he spent all the time trying to compute examples. I don't know why he had like 6 examples, and we didn't have time to actually do the main topic, which was this Riemann Lebesgue lemma. But I guess I'll do this anyway. Let's see the questions or the problems. So I guess this is some insight into how it is actually studying mathematics, like doing a bachelor's. So for Tuesday tomorrow, oh, I read that. Did I read it wrong? No, I didn't. It's 2.22. Compute the following integrals taken over the entire real axis if nothing else is indicated. I see. Oh, okay. Okay, this is. I'm not gonna get this on the first try. I need to read. And distributions, I was hella confused when that was covered during the lecture. Whoa, what is this? The frick? Okay, so we have so it's over the real line if nothing else is stated, I guess. And we have t squared plus 3t delta t minus delta t plus 2. So this is the delta function, or okay, I'm just gonna read this. Oh, is the mic okay? Is it maybe I'm mumbling a little? I'm not really sure. If the rain sounds too loud, or if it's too quiet, or if my mic is too loud or quiet, feel free to write that down. It's perfect? Alright. Thanks for the feedback, Sanjanta. I appreciate it. Okay, let's read this. For your analysis. So this course is basically for your analysis. like an introduction to that. Do- Mm. 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 There is an interval and that is a function of y such that possibly proper integral has a finite value. Defines any interval. Huh. Okay, yeah. Okay. That's cool. So I was talking to my friend and the seminar teacher yesterday about what it means to be absolutely integrable, and this text actually really helps. Thank you very much. So for all intervals in the real numbers, the proper or the definite integral, the absolute value of that function is defined. Okay, so it basically says okay. Assume that f is piecewise constant. Which means that I is still necessary to compact. guess that makes sense. If an arbitrary function is Riemann integrable, would I be okay, this doesn't make sense. We have a function called f to be integrable. There's a piecewise function like this. I've never really seen it written like that, but I guess that makes sense. When writing Riemann integrals, we can view this function, this tops of each rectangular approximation of the area to be a piecewise function, where this we call ck as being the constant and gk being defined on the interval a k plus 1 having defined a certain partition, right? And if it's Riemann integrable, we can make yes. Yeah, so there exists so since f Riemannical, there exists a certain n such that so I'm not sure the notation, such that the partition or like the mesh size of the partition can be made arbitrarily small for all epsilon greater than 0. This is very messily written though, but I guess the concept makes sense, which is actually kind of cool. So we can make f being an arbitrary Riemann integrable function and g being a piecewise function. We can make the difference like this. let g be a function whose integral is a Riemann sum of f. Whose integral... Oh yeah, exactly. So then we have that this is f of u, and we can... Oh, okay. Yes, we add by 0 here, and we use the triangle inequality, and then we bound sine by 1, then we have something we can make arbitrarily small, and then we have something which we know is 0. Therefore, the limit converges to 0. Fantastic. Thus, the integral tends to 0 as lambda goes to infinity by preceding case. Thus, there is a value at lambda is naught, such that this integral is less than epsilon naught for all lambda greater than lambda naught. For these lambda, the left-hand member is thus less than epsilon, which proves the assertion. Finally, we no longer require i's compact. Indeed. There is a compact subinterval. So I can be any interval. So it can be like interval going to infinity, or it can be the entire R, I'm guessing. Honestly, I'm not sure if this is even anyone watching can even follow what I'm doing. I'm not even sure. I'm also working on maths. What time do you plan to sleep? I am planning to actually sleep in maybe a couple minutes. It's getting quite late. I'm kind of frustrated I wasn't able to do much today. I'll probably start streaming tomorrow fairly early. But then again, I have a lecture. Maybe I'll just have to sacrifice a lot of sleep. That's the tasteless. Okay. I'm not exactly what to do. I'm kind of in a pickle, if I can say that. But yeah, good luck with your maths. What maths are you doing, April? What kind of maths? Because I'm interested. I am very interested. Finally, okay, so this is kind of confusing. Such that integral I take away j is less than epsilon. For an epsilon, we can make this additional maths. I'm currently in elementary school. Wow, okay. Elementary school. Alright, well, good luck with that. Good luck with that. So what grade? Is that like 8th grade? I guess this maths is kind of hard to follow in that if you're in elementary grade. Where the first term tends to 0 by the preceding case, I guess it is less than epsilon to 0 by the preceding case. This is less than epsilon. The second term is always less than epsilon. This is complex proof. Frick. Grade 9. Oh, okay. Yeah, so you're about to start high school, I guess. And let's ask ChatGPT. Let's ask ChatGPT. Now if we have someone that actually understands what I'm doing, I'm probably not doing a good job explaining exactly what I'm doing, but at the same time it's not really the point. I'm just hanging around. There is value lambda naught, so let epsilon be greater than 0, be prescribed. Oh, frick. Alright, I'm just gonna ask ChatGPT. Maybe it's not really that important, actually. Maybe if I'm actually a responsible or like time efficient human, I shouldn't be doing this. But here we go, ChatGPT. But whatever, I'm gonna do it. So I don't really understand a certain thing. So I'm just gonna copy what I'm doing. Or like the proof I'm reading. And then I'll just ask ChatGPT. This is a pro tip. But I guess you have to be fairly careful not to instead view ChatGPT as a fellow student or like a fellow math like friend, not really an authority, but rather a tutor or a fellow math student of the course you're taking. So we'll ask him. Oh freak! Can I type? Oh man. Okay, whatever. Okay. I don't understand. The fourth step in the proof of the remaining Lebesgue lemma or theorem. How is it that if f is absolutely integrable, there is this complex subintegral that we can find a compact subinterval j of I such that the integral I take away j is less than epsilon for every epsilon. This is kind of what I'm stuck at. This is also what does L superscript 1 mean? I'm guessing, yeah, I guess it means f is absolutely, okay, I have no idea. Maybe L has something to do with Lebesgue, or I don't know. Okay, there's a yeah, we want to prove there's this compact subinterval. What does F being absolutely integrable mean? By definition, F in L superscript 1I means this is convergent for, so is it, okay, yeah. This is called absolute continuity of the Lebesgue integral, or sometimes an approximation of compact test results. It is a consequence of inner regularity of the Lebesgue measure. Why can we take J to be an integral? Hello Demo Dog, welcome. Welcome, welcome. Hopefully things are good. How am I doing? I'm doing pretty well. I'm very bad when it comes to time. I'm actually really behind. Okay, maybe not that much behind, but if I don't really take it seriously now, I can be kind of behind. Intuition content of the theorem. Okay, I'm just gonna skip it for now, and hopefully I can ask someone during the lecture tomorrow to explain it to me. I think L1 means integrable. I think so, but I don't know what the 1 means, and I think it means that it's absolutely integrable. Let's just ask. It's very easy to ask. What does L superscript 1 of I mean? That F is absolutely integrable? What does the superscript? Something like that. Okay, so it's the space of all equivalence classes of measurable functions, F, from I to R, such as the absolute okay, first of all, I have no idea what measurable functions mean. What measure are we working with? Like, is it the Lebesgue measure? I think it's something to do with Lebesgue measure. The only thing I know is that if a set is uncountably large, the Lebesgue measure is non-zero, and if it's countable, is zero. How it is with functions, I have no idea. Superscript, that one is connected to the so-called p-norms in analysis. I know the p-norms. Oh, okay, so it defines a norm, a certain norm for which the... Okay, well, I'm not going to go into it. It's not really covered in the text, so I'm not going to do it. I'll probably do that in another coming course next semester. On measure theory I'm having. The intuitive concept of the theory is not to understand for large values of absolute integrated function. Fu sine u is an amplitude modulated sine function with a high frequency. Buffering. Its mean value over a fixed interval should reasonably approach zero as the frequency increases. Of course, the factor sign is lambda u in the integral can be replaced by cos for the complex function with the same result, and of course we can just as well let lambda tend to negative infinity. Okay. The integrated function is an amplitude modulated sine function. with high frequency. Yeah, exactly. So the amplitude changes depending on f of u, and the frequency changes depending on y. And its high frequency is lambda tends to infinity, maybe? Its mean over a fixed interval should reasonably approach 0 as the frequency increases. Started finding your channel back when I was still doing my physics masters, and you're still a complete scrub at maths. Wait, what does that mean? I see the project you made, keep it up, and be wary of ChatGPT. It can be pretty dodgy at times outside of textbook stuff. Yeah, I guess I just now experienced that, eh? Man, the camera is so high up. I should change that. I can't. Alright, well, thanks, Abbas, for following the channel. And hopefully, I think you're done with your master's in physics. What are you doing now? Are you doing your PhD or what? Yeah, indeed, ChatGPT can be very dodgy. I mean, today I had some questions and it totally gave me the wrong answer. It like totally gave me the wrong answer. I need to do the questions for frick's sakes. By the way, distributions. I have little clue when it comes to distribution. Making money, bro. I see. Joining the industry. Fair enough. That's nice. What are you working on? What company or what are you doing? You know, I'm dabbling in that area. I'm a TA now, which is interesting. I do PhD for oral purposes. Fair enough. Though I heard, I'm hearing that PhDs are kind of awful. Or, they're not awful. But, yeah, it takes a lot of work, so, yeah. I think I need to look at my notes for the previous lecture, since... where are my things? Yeah, I know we did a lot of these delta... I mean, Abbas, you probably know all about delta functions, right? Or the delta distribution, whatever it's called. Actually, I'm having a whole time understanding it. Apparently you can view it as a point mass. So, okay, let's write some things down to wrap my tiny brain around what it actually means. Like, it's a distribution given any function, or maybe any continuous function, I'm not really sure, but given any function, it outputs the function defined at 0, right? And how can this distribution be regarded as a point mass? I heard my lecturer say this. We need all big brains in the chat to actually help me. I need help. Oh, here we go. Ground wall inequality. Differential. No, this is ODE. Here we go. So we did some distribution stuff. Let me see if I can find this. Yeah, so apparently my lecturer said that the book was kind of horrible when it came to actually talking about distributions. But apparently he wrote down this, and apparently this makes no sense since delta is a distribution and an input variable which is a function. So this is like a mnemonic device maybe, like it doesn't really have any formal meaning, but I can use this when calculating the derivative. So basically what I'm supposed to calculate is well, I think I wrote it down even here. Yeah, this derivative. Abbas, can you help me? Have you left the chat? If so, I'm kind of screwed. To be fair, I should have like a second camera that can view this, like my notes, like my physical notes, because I find it. I do write things like on paper sometimes, or most of the time. I'm very tempted just to ask ChatGPT. We had this. And we had easier than it's actually really easy actually. I'm overthinking it. So we know by this definition here that this can be written as, so this is our phi, so we just evaluate it at 0. Then again, I'm not really sure what the bounds are when I write this. Oh, it's R. Well, then we're done. But this, I'm not really sure what I'm doing. So it's just and here in this case, this is kind of interesting, since you should evaluate this. I have an example where we have t minus, so this should be evaluated at -2 squared, -3 times 2, which is equal to 4, -6, which is equal to -2, which is equal, I guess the whole expression is equal to 2. So I guess this is the answer by using that. But I want to, maybe I'll just read the text thing. We shall now show how, okay, let's actually, basically, so it's chapter 2.5 to 2.6. 2.5, 2.6. Okay, so this is 2.6, which is on, yeah, so let's try to read this. We introduce an informal way, sort of generalization of the notion of a function. A more coherent and systematic way of defining these objects is given in chapters 8. As motivation of this generalization, we begin with a few examples. Section 1.3, on the wave equation, we saw difficulties in the usual requirement that solutions of the differential equation of order n shall actually have maybe even continuous derivatives of order n. Quite natural solution of the following, but are more of a bureaucratic nature than physical nature. This indicates that which would be good to white a certain final amount of electric charge localized at one point in space. Charge density is infinite at this point, but the charge itself has an exact finite value. What mathematical object describes this? Huh. Is that complicated? Can we invent a mathematical object that is the limit of such a sequence? Positive. T not 0. There's no ordinary. Okay. only the reason is we're given his name to the object delta by delta function. What are you thinking? Alright. Not much is explained in this text. We can second over some input that contains the origin in its interior. We also introduced the translate delta A, which can be described by either delta A and T. Alright, this is fairly frustrating, not gonna lie. I don't even know what is going on. It seems as though we're using mechanics that we're not even defining, which is interesting. Yeah, okay, this is not really helping. I'm just gonna try to cheat my way with these exercises. I don't think I'll be able to do much more. B 0 to infinity negative is t delta prime of t negative 1 to t. So I remember that delta prime of t phi is equal to negative phi prime. So, yeah. Okay, so what I'm wondering is, it's not really to 0 or like to negative infinity here, but I don't think that matters. Like, is this just equal to negative 1 e negative 1 times t wait. No. Yeah, like this. I think this is okay. I'm guessing all physicists have left the chat. But I'm not sure. I'll ask ChatGPT. This is the correct outcome. I think it is, compared to, or like, compared to what I did during the lecture. So I'm not really sure. What? Can you solve this, please? Yeah, I'll just say this. It'll work out well, I think. I mean, maybe you could argue that it's kind of cheating, or if it's not maybe beneficial to your understanding if you just say to solve something, but I think it's fine. Especially in this case, it's I have given my effort, and yeah, I guess it's fine in that way. It's actually quite late. I'm actually having a really fun time doing the stream. I've been live for around 1 hour. I'm actually considering doing this kind of stream tomorrow morning, and then doing a study with me stream maybe in the afternoon. I'm not really sure. Haven't really decided. Or maybe I'll just do in the morning like a normal stream, and then in the evening like this, like a chill with me stream. I'm not sure. Correct. Right, so I forgot a negative sign. No! Yeah, so I just forgot a negative sign. Yeah, true. Yeah, so it's supposed to be extra negatives there. And like that. There's supposed to be a negative 2, I think. Support is a T naught, and T is included fully, so okay. Oh yeah, that's true. Yes, this goes away. Yeah. That makes sense. Alright, well I guess that was easier than I thought. I guess. I'll have to transfer these answers to my other notebook. Oh, this is a good one. So, what does this mean? This is the same as T plus T. Ah man, I'm tired. This is not. Can I solve this? What more questions do you have? 22, 24. Alright, let's see. 26, 29. 26, 29. Okay, this one I actually want to do. This one I really want to do actually. Yeah, that one I really want to do. Do we have any physicists in the chat? I don't know how many times I said this. Probably not. No one's answering. But the only thing I know is that the delta function is something very commonly used by physicists. And I have no idea what the frick it is. Or I guess I have a limited understanding. I have some understanding, but it's very limited. Let's see here. Am I missing something? I don't know what it means, honestly. Oh, it's getting so late. express it as something. Can I? This is probably not how you do it. No, it's not how you do it. Manipulating in a suitable way. Can I take the derivative somehow? I know the derivative. I guess I need to have a function. Maybe not. It doesn't really make sense. Or maybe it does. Like, I know this. And I need a hint. I need a hint. Sub hint. Let's see if actually ChatGPT actually helps. If it actually gives a hint or not. I mean, usually in the older models they give like solutions. If you say you want a hint, it gives like the full solution. Okay, here's a nudge without giving it away. Take a smooth text test function. Look at this. Take the U substitution. Well, I mean, and we write the integrand as remember the delta sifts a test function, and also remember that the delta is even. Do that for 2, then repeat for a general. Use the evenness at the end to handle the sign. I guess we can do a U sub. So with this U sub, we have phi of t half, I think. No, U half. Delta U t du. Yeah, I think that's. Or I think we need a half as well. How in the world does this help me? Brr. With my work, probably can sleep soon because it seems pretty late. Yeah, it does. It is pretty late. But honestly, I don't really understand this problem. I have no idea what they mean. We can do a U sub. And we can get this. We can evaluate this at I mean, sure, we can do this, and then we can evaluate this at 0, 2, which is the same as half 5, 0. Still not getting it. Okay, well, I guess I got the right answer, but it seems kind of wrong. Yeah, so I guess we view dt so in the general case we have okay, I guess that makes sense. We write using the heavy-sided expression f1 of t plus 1 if Right, the heavy side function. Yikes. I think the heaviside function is just actually I'm not really sure. Interesting. So I guess T, so if T is positive, we have T squared, right? I guess it has a root at -1. And maybe I shouldn't graph these functions before. So how do I rewrite this using upside? Right, so, okay. So, I guess we split by case, so t plus 1 greater than or equal to 0. So t is greater than or equal to -1. In this case we have t squared plus 1 plus t, and it's a positive second order function with root at -1. So I mean, it should look something like this, I guess. I don't know, like that. When it's negative, we have negative. So when this is less than -1, we have that negation. So it's negative t squared minus t, and I guess it still has a root here, but it's the opposite direction. Something like that, I guess. I may be wrong though. But it feels right. Feels right. So how would you do this with the heavy side functional thing? Oh. So I guess I can do it with t minus 1, and then I can multiply it by t plus 1, and then I can do negative. Never mind, I do this is positive. And then we have h of Let's see here. Maybe I'm doing everything wrong. Expect this more effective for me. Please try to do such streams in the future. Yeah, I mean, I find that these streams are good, but I would have liked more conversations. But certainly I do want to improve. Like I was thinking today, like what? I was actually looking back. I don't know if I want to start it. Like, if I want to really explain it, like I was during the teaching, like the exercise class. Someone recognized my like the YouTube channel and stuff, and I was thinking like, yeah, that's cool, and I wish I did more with the channel and stuff. So I was wondering what exactly what I really wanted to do, and I feel like when I started with the channel, I was not doing it for anything other than myself. I didn't really care that much. I mean, if no one watched, I didn't care. If many watched, I didn't really care. In the end, I kind of didn't feel like I needed to rely that much on the videos anymore, since I did everything I wanted to do. So it has been like a slow decay in motivation and video quality. But I wanted to find something that I can do without really caring about any like views or whatever. And I feel like something regarding mathematics is certainly, or like something like this is good. Granted, I'm not really sure how to make it well and stuff, but at least I'm enjoying myself. And I really do want to be good at mathematics. That's still one of my primary goals. But yeah, I'm still looking for physicists in the chat. Okay, maybe I won't find any physicists. But nonetheless, I think I'll just end it here. It's freaking late as late, and I should go to bed. Sadly, I couldn't really do anything, much of the exercises, which is fine, I guess. But yeah, I don't think it's that big of a deal. I honestly don't think that many of my classmates also understand what's going on with the distributions, so it's not really that big of a deal. I think I'll still be able to follow along with the lectures anyway tomorrow, which is good, you know. I'm happy about that. But I'll certainly try to do these exercises tomorrow morning. Anyways, it was fun doing the stream. I'll continue doing this, like I said. At least I'll try, but also I'll probably do also like the normal streams. I'm not sure, like this camera angle is fairly interesting. I don't really know if I'll do more. The only problem with it is that the camera's so high up. It's kind of crazy. Anyways, I'll just end it here. I'll see you guys tomorrow. And yeah, sadly no one joined me in the Discord, but hopefully that'll be something of the past if I do more streams like this. So yeah, I'll see you guys.